Good morning, students. Now I think you must have solved many problems. You must have done the practice. અને હવે આપણે પ્રેક્ટિસનો થોડો આગળનો ભાગ આપણે કરવાનો છે. વિધાઉટ યોર પ્રેક્ટિસ ઇઝ નોટ પોસિબલ ટુ ડુ ઇટ. એટલે તમને ખાસ યુ ડુ મોર એન્ડ મોર પ્રેક્ટિસ. જે આપણે વધારે મોટા પ્રોબ્લેમ સોલ્વ કરતા હોઈએ તો બરાબર છે, એમાં જરૂર તમારા ટીચરની પડતી, પણ ત્યારે નાના નાના પ્રોબ્લેમ્સ હોય તો યુ હેવ ટુ ડુ ઇટ. તમે જ્યારે પ્રેક્ટિસ કરશો ત્યારે તમારી સ્પીડ વધશે, અને જ્યારે મોટા મોટા પ્રોબ્લેમ આપણે કરીએ ત્યારે તમારું થિંકિંગ વધે. અને જ્યાં સુધી એકલા થિંકિંગથી કામ નથી ચાલતું, એકલે પ્રેક્ટિસથી બી કામ નથી ચાલતું, વી નીડ બોથ. તો જે થિંકિંગ પ્રોસેસ કેમ સ્ટાર્ટ કરી, બીકોઝ ઓફ ધેટ ઓનલી વી આર સોલ્વિંગ સો મેની ક્રિટિકલ થિંકિંગ બેઝ પ્રોબ્લેમ્સ. પણ એના આધારે તમે આવા નાના નાના પ્રોબ્લેમ જો તમે જાતે કરતા શીખી જશો તો તમે ઘણું બધું સારું પરિણામ આપી શકશો. સો આઈ હોપ કે તમે બધા ખૂબ સરસ રીતે આ વર્ક કરશો. તેમ છતાં આપણે થોડા હજી વધારે નાના નાના પ્રોબ્લેમ્સ કરવાના છે, અને આ બધા તમે જોશો તો પૂછાઈ ગયેલા છે કે કોઈને કોઈ રીતે બહુ ડિફિકલ્ટ નથી હોતા. In Young's double slit experiment, when the wavelength is used 6000 angstrom are screened 40 centimeter from the slit, the fringes are 0.012 centimeter wide. What is the distance between the slits? So this is your lambda is equal to 6000 angstrom. I always said that the answer is centimeter. So from the beginning you convert into centimeter. So this is in centimeter. Screen is how far? The 40 centimeters. So capital D is 40 centimeter. The fringes are wide. So beta is equal to 0.012 centimeter. Now and calculate the distance small d. So it's very simple problem. Beta is equal to lambda capital D upon small d, which implies that small d is equal to lambda d upon beta. So lambda is 6000 into 10 raised to minus 8, capital D is 40 divided by beta is 0.012. Okay, so 3 0, so it will become 5. This is okay, this 0 is going, so it becomes minus 4. This is 1 2, so going up, so 1 2 3, sorry, so again it becomes plus 3. So now it is 12, so 6 2s are 12, 2 2s are 4. Okay, so it is 2 into 10 raised to minus 1, so answer I think 0.2. So this is I think answer. Okay, so you can see that these calculations are not that much lengthy. What will be the angular width of the central maxima in the front of a diffraction when light wavelength is this much used? Slit width is 12 into 10 raised to minus 5. So this is a problem of diffraction. So this is our screen, and you know that this is the central maxima, and here we are required this angle. Okay, when you draw the figure, it becomes picture more clear. You know that this is the first minima, so distance from the central to the first minima. એ મારું કેટલું થાય? We use condition for the minima. Minima ની condition મારે apply કરવાની. So we have d sin theta is equal to n lambda. It is condition for minima. તમને એમ થાય question is asked for maxima, and we are using minima because up to here maxima is spread up to here. Okay, so sin theta is equal to n is equal to 1, so into lambda is equal to 6000 angstrom. In the centimeter, so I write in centimeter only, so n raised to minus 8 divided by small d. Small d is 12 into 10 raised to minus 5. So this comes out to be, this 3 is going up, 5 minus cancel, so it is 1 by 2 radian. So sin theta is equal to 1 by 2 radian, and it is a small value, so you can directly write the theta is equal to half radian. So many students are making a mistake over here. See, if option is given 1 by 2, so when you get this answer, you may easily pick this answer. No, this is theta here. Actually, I want this theta, so it is double of that. So okay, so this is actually not theta, it is 2 theta from here to here. અહીંયા જો theta કહો તો આને 2 theta મારે કહેવું પડે. Okay, so this is 2 theta, I have to multiply by 2, so it becomes 1 radian. Okay, so this is actually, again I tell you, in fact this theta is not that small. Huh? Theta is not that much small. અહીં sin theta equal to theta ન લઈ શકાય. Actually I have to find out this radian and then I have to convert into I cannot use this. I have to use tan theta. મારે શું યુઝ કરવું પડે? tan theta. પણ અહીંયા આના બેઝ ઉપર સોલ્વ થઈ જાય છે. The maximum intensity of the fringes in the Young's experiment is I. If one of the slit is closed, then the intensity at the place becomes I0. What is the relation between that? So if both the intensity are equal, then center maxima, what is the intensity? That is 4I0. That is one formula. But here it is I. So I don't want to use this 4I0 is the intensity of the incident light. Okay, so this is your, the intensity at the place become I0. So initially it is this much. And when one is closed, it becomes I0. So actually what is happening, so when this is our Young double slit experiment, we are putting a slit, so here center maxima any intensity 4 times more. Suppose this is I say this is I0, this is I0, it becomes 4I0. When you remove this, it immediately becomes I0. So 4I0 is called I and this is I0. So what is the relation? So I is equal to 4I0. This is our relation. Okay. Then in Young double slit, in an experiment, two coherent sources are placed at 0.9 millimeter apart, and so this is D is equal to 0.9 millimeter. Okay, and the fringes are observed 1 meter away. So this is capital D is equal to 1 meter. If it produces the second dark fringe at a distance 1 millimeter from the center second dark, so I say x prime 2 is equal to 1 millimeter from the center fringe. This wavelength monochromatic light is, what is that? Okay, so this is again when you do the picture, so this is your center maxima, this is your first maxima, this is your second maxima. Okay, in between you have, this is first minima, this is second minima. So what is given? Second minima. So this distance is given. Okay, where you get this point, એ આપણને ખબર હોવી જોઈએ. So એ point આપણને મળશે, તો આપણી પાસે ફોર્મ્યુલા છે sin theta d sin theta is equal to 2n minus 1 lambda by 2, where this is the condition for the minima, and second one is, અહીંયાથી હું જો આ રીતે કરી નાખું, this angle is theta, this is capital D, so we can write x prime 2 upon capital D is equal to tan theta is equal to sin theta, and sin theta is equal to what? If you put n is equal to 2, isn't it? N is equal to second fringe, yes. So 2 minus 3, so 3 lambda by 2. Sorry. Sin theta is equal to 3 lambda by 2 and this D is going down. Okay. તો આપણે calculation કોની કરવાની છે? તો આપણે calculation કરવાની છે wavelength ની. So I combine these two things. So what I am getting is this lambda is equal to this x2 prime small d multiply by 2 divided by 3 into d. So we put all this value, small d is not there. No, it is there, yes. So this is millimeter, this is meter. So I write multiply by minus 2 multiply by minus 2. Okay. So what we get, 2 into x2, so it is 1 millimeter 10 raised to minus 2. D is 0.9 into 10 raised to minus 2 divided by 3D, so 1. So now we simplify this. What we get, this is 2 into 10 raised to minus 2, again minus 2, this is 0.9, so I take minus 1, so 9 multiply by 9 divided by 3, so 3 ja, so 6 into 10 raised to minus 5. This is in meter, because we have used meter. So what are the options? It is options are in centimeter. So this is 6 into 10 raised to minus 3 centimeter. So where is that? Okay, this is the option 60 into 10 raised to minus 4. 60 into 10 raised to minus 4. I can write it? Yes, we can write. So this is the answer for you. So two coherent sources of intensity ratio. So I1 upon I2 is equal to 1 upon 4. Produce an interference pattern. Then what is the visibility? So we know to find the visibility we have to find I max and I mean. So first I write A1 upon A2 is equal to 1 by 2. Now you know that it is proportional to root I. And therefore A1 plus A2 upon A1 minus A2 is equal to 3 by 1. And therefore I max upon I mean is equal to 9 by 1, because intensity proportional to amplitude square. And therefore I max minus I mean upon I max plus I mean is equal to 9 minus 1 upon 9 plus 1. So 8 by 10. So this is 0.8. So this is called visibility. I max minus I mean upon I max plus I mean. So this is the correct option, I think so. A light wave is incident normally over a slit of width 24 into 10 raised to minus 5 centimeter. The angular position of the second dark fringe from the center maxima is 30 degree. What is the wavelength of light? So this is the width of the slit. So this is small d. Okay, or you can A also. In our text we have used A. The angular position of the second dark. So second dark. So we have d sine theta is equal to n lambda for dark fringes. Okay, light is normally over a slit. So this is a one slit problem, which means it is of diffraction. So n is equal to 2. Therefore we write d sine theta is equal to 2 lambda. Okay, so theta is equal to 30 degree. So d is equal to what? 24 into 10 raised to minus 5 into sine 30, okay, divided by 2 is equal to your wavelength. So 2 12 ja, and this sine 30 is again half. So this is half. So half cancels, so it becomes 6. So 6 into 10 raised to minus 5, that is in meter. So 6000 angstrom. So that is your answer. Again we have taken here approximation. Sin theta is equal to tan theta. When a compact disk is illuminated by source of white light, color lengths are observed. This is due to, you must have seen that floppy આવતી તમને CD drive, CD ચલાવવાની એની વાત કરે છે compact disk. So when you see it, it looks colored. So this is because of the diffraction. This is because of the diffraction. Not dispersion, not interference, but it is because of the diffraction. Diffraction and interference of light suggests that nature of light is electromagnetic. Electromagnetic એનાથી આપણે ના કહી શકીએ. Wave nature, yes, of course, wave nature. those having wave nature gives the phenomena diffraction and interference. આ ટાઈપના ક્વેશ્ચન બી આવે છે. તમને એમ થાય કે આવો ક્વેશ્ચન તો વિધાઉટ એની કેલ્ક્યુલેશન તમને આમાં આન્સર આપો તો તમને રોકડા માર્ક મળી જાય. ઇટ ટેક્સ ઓનલી ફ્યુ સેકન્ડ. કારણ કે તમારે મિનિટોમાં આન્સર આપી શકાય ત્યારે ઇટ ટેક્સ ઓનલી ફ્યુ સેકન્ડ. તો તમારે આ ટાઈપના ક્વેશ્ચન્સ લોજિકલી થિંકિંગ કરીને સમજણ ઉપર આધારિત પ્રશ્નો પૂછાતા હોય છે. તો આના માટે ખાસ સમજવું જરૂરી છે. To observe diffraction, the size of an obstacle should be the same order as the wavelength, should be larger than the wavelength, have a no relation, there is a relation. Actually, whenever you have suppose obstacle and a wave is coming over here, so how can if this wavelength is very greater than A, તો તમને વધારે ટર્ન થશે. But at least you require of the order of A. આ પહેલા ક્વેશ્ચન હતો તો એમાં થોડુંક એવું હતું, મેં એવું વિચાર્યું હતું કે when you get maximum, so if this condition is satisfied, you get more diffraction phenomena. અહીંયા સુધી તમે જોઈ શકો, and if this is less than that, you cannot see the diffraction phenomena. So this is the correct option. In a far field diffraction pattern of a single slit under polychromatic illumination, the first minimum with the wavelength lambda 1 is found to be coincide with the third maximum at lambda 2, so that actually light is not a single color, it is polychromatic, means many colors are mixed. So for different color we have different conditions. So first minima મને મળતું હોય, it means d sin theta is equal to lambda 1. So this is for one color, and at the same angle you are getting third maxima. So I can write the condition d sin the condition for the third maxima ni condition 2n plus 1. Okay, so this is multiplied by 3 plus 1 and lambda by 2, but this is lambda 2. So this angle is same, this angle is same, left side equals, so right side also equals. So lambda 1 is equal to 3 2 ja 6 plus 7, so 7 by 2 lambda 2. So this is the relation. So lambda 1 this is 3.5 lambda 2. A polaroid is placed at 45 degree to an incoming light of intensity I0. Now the intensity of the light passing through polaroid after polarization would be. So actually this should be spaced at 45 degree with the electric field vector, and incident light must be polarized light. Then this problem is worth to us, otherwise there is meaningless. Okay, so I think we understand it is already given, and then we do the calculation. We know that what is the intensity after passing through the polaroid. So I is equal to I0 cos square theta. So you should know this formula. So incident light is I0 cos square, what is the angle? That is a 45 degree, cos 45 degree is 1 upon root 2, and then it is squared, so it will be I2. So option is B is the correct one. Okay, if light is unpolarized and incident on the polaroid, then whatever the intensity here, it becomes I by 2. તમને રિવાઇઝ કરાવી દઉં. Intensity is I, then it becomes I by 2. Whether incident light is polarized and unpolarized or partially, how you can come to know that? If you rotate your polarizer, intensity doesn't change, means incident light is unpolarized. If intensity varies maximum to minimum, minimum to maximum, then it is partially polarized. And if intensity varies maximum to 0 and 0 to maximum, it is polarized. Okay, so you should know this thing. We already discussed in the theory part. One more question based on the polarization. Figure represents a glass plate placed vertically on a horizontal table with a beam of unpolarized light. So you can see this is unpolarized, it is symbol of unpolarized light. Surface at an polarized angle 57 degree with the normal. The electric vector in the reflection light on the screen S will vibrate with respect to the plane of incident in. Okay. Okay. So here like that, this is the vertical plane, and this light is incident over here, okay, and it is reflected. So when this angle is angle of polarization, so this becomes polarized light. And electric field vector always perpendicular to the plane of incident. So this is the plane of incident and a perpendicular means here. So it becomes um, light is incident like that. It's coming out. So this is the plane of, yes, this is your plane of incident. And a perpendicular means like that. So it is a vertical. It is a vertical is the answer. This light is coming and going like that. Okay. આવી રીતે થાય છે. મેં આવું એવું નથી. It like that. So this answer is vertical. If like that, the answer શું આવે? Horizontal આવે. Okay. Then next one. A beam of light AO is incident on a glass slab in the direction as shown in the figure. The reflected ray OB is passed through the Nicol prism on viewing through the Nicol prism. Nicol prism one type of polarizer only. We find the rotating the prism that. So first you should know what is this angle? 33 subtract, so it is 57. Okay. So if you check n is equal to tan theta and tan 57, so if tan 57 is equal to 1.54, it is supposed to be given, then and then you comes to know. So it is 1.54, 54. So what is happening? This is angle of polarization. So this is polarized light. So if polarized light is passing through Nicol prism and Nicol prism is rotated, the intensity becomes maximum 0, as I discussed in last problem. So intensity reduced down to 0 and remains 0. No. The intensity reduced down somewhat and rises again. There is no change in the intensity. Intensity will definitely change. The intensity gradually reduced to 0 and then again increase. So this is the correct answer. If you are not getting this value, n is equal to 1.54, it means it is partially polarized. Then my second option is correct. But if n is equal to tan theta, then fourth option is correct. So be careful. So this angle must be angle of polarization. તો આવું બનશે. And if this angle is not angle of polarization, તો મારું કયું આવશે? બીજું આવશે. Okay. You know the booster law. This is nothing but booster law. અને જો air ન હોય તો I have to use relative refractive index. One has to use relative refractive index if surrounding is not air. A light has amplitude A and angle between analyzer and polarizer is 60 degree. Light is reflected by analyzer has amplitude. It is not reflected, it must be refracted. Okay. So we know that intensity is equal to I0 cos square 60 degree. So I0 cos square 60 degree is equal to 1 by 4. Okay, so it is I0 by 4. But here question is not of that intensity, it is a question of amplitude. So we know that amplitude proportional to root I. Therefore, amplitude becomes A0 by 2. So I think option D is the correct one. Okay. In case of linearly polarized light, the magnitude of the electric field vector does not change with time, varies periodically with time, increases and decreases linearly with time, is parallel to the direction of propagation. No, this is not correct. Does not change, will change. It varies periodically. It obeys this, what you say, sine or cosine function. Okay. a ray of light of incidence I is incident on a parallel glass plate. Here light આવે છે, reflect થાય, then somewhere refracted, again reflect and refracted. At each reflection, 25% of incident energy is reflected, means 75 refracted. The rays AB and AB prime, AB and A prime B prime undergo interference, the ratio of that. તો આની બંને વચ્ચેનું મારે શું શોધવાનું છે? ઇન્ટરફેરન્સ શોધવાનું. So અહીંયા હું I કહું છું, so let us say this is I1, this I say I2, this I say I3, and this I say I4. So interference is taking place between I1 and I4. So I should find out what is I1 in terms of I, what is I4 in terms of I. Okay. So what is I1? So I1 is 25% of I. This is 75%. So again this is reflected. So I3 is equal to 25% of I2. And what is I2? So that is 75% of I. Okay. Again there is a. So this is 25% of I3. And this is 75% of I3. So I find out I4. So I4 is equal to 75% of I3. Okay. So I put I3. So 75 upon 100. I3 is 25 upon 100. 75 upon 100 I. So now I4 and I1 both are in terms of I. So now I write again here, I1 is equal to 25 upon 100 I, and I4 is equal to 25 upon 100, 75 square upon 100 square I. Okay. Now you have to find out I max and I mean. તો તમને ફોર્મ્યુલા યાદ હશે. I max means root I1 plus root I2 whole square. યાદ આવી ગયું? Because root I1 because it is amplitude. This is amplitude 2, amplitude proportional to root I. So root I1 if I take, then it is 5 by 10 I root I plus I2 is equal to root of this is 5 upon 10 and this is 75 upon 100 root I. So this is you can calculate 5 by 10, so 0.5 root I plus 0.5 into 0.75 root I, and I take the common. What I take common? Root 5 root I common, I take common, so 1 plus 0.75. So this is 0.5 root I, 1.75. Okay, so this is for I max, and if I minimum, then just I have to put the negative sign here. So if I put negative sign here, it becomes 0.25. So I minimum, કારણ કે એમ્પ્લિટ્યુડનું સબસ્ટ્રક્શન થશે, so root I1 minus root I2 square. So here on a negative sign, so you will get 0.5 root I, 1 minus this is a 0.25. Okay, now we take the ratio of this two. So this I max upon I mean is equal to this upon this. So what you will get, this will cancel, 1.7 is 7 divided by 1. So option is, I think, C. This is a very good problem, right? બહુ સારો problem છે. અને અહીંયા one more, you note down one more thing, okay, if this is denser and this is rarer, so a light arm just reflects, there is no change in the phase difference. but if this is rarer and this is denser, તો અહીંયા આગળ પાઈ જેટલી ફેઝ વચ્ચે આવું મેં કદાચ પહેલા કીધું હતું, પાઈ ફેઝ will increase. ઓકે, તો ક્યારેક આવું બી પૂછાશે, આ નાના બેઝ ઉપર પ્રોબ્લેમ બી કરશું આપણે. In the adjacent, so here I have already calculated time બચાવવા માટે. So this is theta, so 90 minus theta. So question is at this point we want constructive interference. So one ray directly coming and second ray is coming after reflection, and they are both are meeting. So this ray has to travel how much more distance? C to O or to P. So from geometry you have to calculate CO plus OP મારે calculate કરવાનું છે. તો મેં શું કર્યું, OP શોધવા માટે I have taken this right triangle. Okay, so this is I take cos theta is equal to sin theta is equal to opposite upon this one. Sin theta means 90 minus theta, so it becomes cos theta. So from that you can calculate what is OP, and RP is given, I have taken this R D. So D upon cos theta is your OP. એટલું સમજમાં આવ્યું? This is the right angle, and I take sin 90 minus theta is equal to opposite upon hypotenuse. Sin 90 minus theta is cos theta. So this is cos theta. So OP is equal to RP upon cos theta, and therefore D upon cos theta. So this is already done. હવે આપણે જોઈએ છે મારે OC. શું જોઈએ છે OC? તો OC is one side of this right triangle. એમાંની OP is one hypotenuse. તો અહીંયા હું શું લઈશ? cos 2 theta. What I take? Cos 2 theta is equal to adjacent, that is CO, and divided by hypotenuse OP. What is my CO? So CO is equal to OP cos 2 theta. And મારું total path difference કેટલો થશે? Path difference is equal to O2P and C2O. તો અમે એડ કરી દીધા. O2P અહીંયાથી લઈ આવ્યો તો D upon cos theta, and CO is equal to OP cos 2 theta. એટલે ડાયરેક્ટલી મેં વેલ્યુ મૂકી દીધી છે. OP ની વેલ્યુ અહીંયા મૂકી દીધી, D upon cos theta from here and cos 2 theta. So this is your path difference. But cos 2 theta અહીંયા હું કોમન રાખું છું, D upon cos theta, take common, so 1 plus cos 2 theta, and cos 1 plus cos 2 theta trigonometry no relation 2 cos square theta. 1 cos is cancelled, so we get 2D cos theta. So path difference is 2D cos theta. Path difference is 2D cos theta. એટલું થશે. Okay. Now one wave is coming directly here and second after reflection. તો જ્યારે reflection થાય ત્યારે પાઈ જેટલો ફેઝ વધારાનો એડ થાય. તો અમારી કન્ડિશન છે પાઈ જેટલો ફેઝ વધી જાય એટલે પાઈ ઇઝ કરસ્પોન્ડિંગ ટુ લેમ્ડા બાય 2. ઇટ મીન્સ ધેટ because of the reflection lambda by 2 જેટલો પાથ ઓલરેડી વધી જાય છે. તો હવે કન્ડિશન ફોર કન્સ્ટ્રક્ટિવ lambda by 2 તો છે જ, I need extra lambda by 2. So instead of lambda I have to use lambda by 2. So this is your path difference is equal to lambda by 2 plus જે આપણે આવ્યું હતું તે. તો lambda by 2 ક્યાંથી આવ્યું? because of reflection. અને લેમ્ડા બાય 2 વધારાનું મારું હશે તો શું થશે? મને કન્સ્ટ્રક્ટ ઇન્ટરફેરન્સ મળે. સમજો, પાથ ડિફરન્સ ઇઝ ઇક્વલ ટુ n લેમ્ડા. હવે n ઇઝ ઇક્વલ ટુ 1 માટે લેમ્ડા. તો અહીંયા આગળ લેમ્ડા બાય 2 ઓલરેડી આવે છે અને પ્લસ પાથ ડિફરન્સ, દેટ ઇઝ બીકોઝ ઓફ ધીસ જ્યોમેટ્રી. તો ખરેખર મારે કેટલો જોશે? આ તો ઇઝ ઇક્વલ ટુ લેમ્ડા માઇનસ લેમ્ડા બાય 2. સો ઇટ ઇઝ લેમ્ડા બાય 2. તો અહીંયા મારે લેમ્ડા બાય 2 આવશે કન્ડિશન, નોટ ધ લેમ્ડા. સો 2D cos theta is equal to cos theta lambda by 2, therefore cos theta is equal to lambda by 4D. Be careful, reflection થાય એટલે પાઈ જેટલો ફેઝ વધે છે, because rarer થી denser માં જેને રિફ્લેક્ટ થાય છે. આગલા પ્રોબ્લેમ મેં કીધું હતું ને, પાઈ is corresponding to lambda by 2. એટલે પાથ ડિફરન્સ એકચ્યુઅલી મારો કેટલો હોવો જોઈએ? n લેમ્ડા. પણ lambda by 2 ઓલરેડી વી હેવ because of the reflection. તો હવે મારે લેમ્ડા જોતું હોય તો વધારાનું કેટલું જોશે? lambda by 2 only. ઓકે, આની કન્ડિશન થિયરી બી છે આના માટે, પણ આપણે ટેક્સ્ટમાં નથી, પણ આ એક એક્સ્ટ્રા પ્રોબ્લેમ તરીકે. સો યુ કેન અન્ડરસ્ટેન્ડ cos theta is equal to lambda by 4D is your correct answer. Okay.